Good morning, good afternoon, and good evening to you. I'm really honored to have the opportunity to participate in this exciting event. And based on the number of participants, this is clearly the right time for such a conference. As stated, my name is Greg Camarado, and I've had the pleasure of being part of the Goodyear family for over 37 years. So during that time, I've worked across many regions, business units, and technology functions. My current role is Director of Technical Operations, which essentially covers all of our material and tire testing facilities, prototype development, product development, lean operations, and all of our associated environmental, health, and safety aspects. We have seen an evolution across our industry and in the product development process over the decades. One thing has remained consistent over that time. Regardless of the amount of modeling and predictive capability developed, and there has been huge progress over those many years, there has been an ultimate physical validation required in many of the iterations of the process. However, we are quickly closing in on something very big, an exciting change to our knowledge generation and decision-making process. But before we get into that, I want to introduce our company to you. Next slide, please. The Goodyear Tire and Rubber Company was founded in 1898 with limited money borrowed from the founder's brother-in-law and 13 original employees. So you could really say Goodyear was one of the original startup companies. It was a time of transition in transportation, moving from horse-drawn carriages to early automobiles, a true inflection point in our industry and frankly, in the world as it was at that time. Obviously, our company has grown since then with business, technical, and manufacturing operations in almost every corner of the world to become one of the most recognized tire brands in the world. Next slide, please. Like our founder, Frank Seiberling, and others saw so many years ago, we recognize another inflection point in mobility. This time it is signified by the emergence of electric vehicles, autonomous vehicles, shared fleets, and connected vehicles. Collectively, this trend grouping comes to be known as FACE. In fact, it is believed we will see more changes over the next decade than we have seen over the past 50 years. Next slide, please. This new inflection point, the transition to growth in electric vehicles, autonomous and connected vehicles, and emergence of consumer fleets, is driving disruptive changes in the tire and automotive industries. In the fleet area, the growth of customer fleets is a big change. While it's important to note that COVID-19 is having a profound effect on this particular trend, we strongly believe this trend will ultimately continue forward. More autonomous or self-driving cars are coming, and we are working in this space along with emphasizing the connected segment in which tires will be equipped with sensors to track and predict operations for vehicle efficiency, avoidance of breakdowns, and an enhancement of overall safety. Nearest term, the onset of EVs is a critical consideration for a tire company. EVs are heavier, have more torque, and need extended mileage range. But all of these represent great opportunities for tires. Ultimately, this has become an opportunity for the tire industry to partner with OEMs to serve our customers. And it becomes another opportunity in the tire vehicle development process. Next slide, please. Historically, the OEM tire company development process has been time-based with a well-understood and expected level of steady evolution as vehicle prototypes evolved, with the goal of achieving the needs and desires of the target customers, along with enhancing the essence of the brands. While historically, the process as depicted in the chart shows a linear approach, many of us know it really can be a bit more challenging with ups and downs at times, but ultimately, the final package, converging and achieving the required performance and specifications normally happens, and the program is ready for final release for production. Today, expectations and the reality of our development cycles requires us to achieve the necessary performance levels and the ultimate package much more quickly. There are many reasons for that, not the least of which are availability and cost of prototypes, the sharing of prototypes across development areas, and the need to respond quickly to the marketplace. Ultimately, this requires a much more efficient and agile development process than in the past. So in times of change, in times when inflection points hit, agility is key. The need to be more responsive, be adaptive, and adjust is clear. How we develop tires and the tire vehicle package must change. So now let's take a look at how we are changing. Next slide, please. Traditionally, Goodyear has been using the finite element method and other modeling technologies to predict tire performance. For the past 27 years, we have developed and advanced FEM techniques in partnership with a premier national engineering laboratory, Sandia National Labs. Under the U.S. Department of Energy, Sandia has a global reputation for developing simulations of complex mechanical systems in high consequence applications. And I am very pleased to say that we have successfully leveraged their expertise and extended it to tire modeling. In recent years, with the ever-increasing computational power and more accurate models, Goodyear is utilizing vehicle simulation environments and now even full dynamic simulators to assess the total vehicle performance. In the tire development environment, this is a major enhancement to our processes. Next slide, please. So why simulators? First, our OEM customers have models representing their vehicles with a high level of fidelity. Second, through our years of development, we know we have the highest level of fidelity in our tire models. Third, we now have the ability to get a high-level representation of the track with all the physics and connections between the tire and the road. When you bring all of this together, tires on a vehicle on a real-world track with a human, a professional trained test driver, with the ability to connect the human to the virtual using the math behind the objective representations, along with the driver's subjective evaluation and information, all brought together through vehicle simulators. We believe we are there now. Drivers and simulator engineers can now evaluate a broader range of design parameters much more efficiently, more repeatably, and certainly much more quickly than with physical prototypes. Simulation holds many benefits for us and OEMs, now and into the future. Although we will still require our real-world facilities, such as Goodyear's global network of test labs and proving grounds, to help further refine our models and validate the prototypes eventually produced through our virtual iteration process. Next slide, please. This chart represents the breadth and depth of Goodyear's global technology footprint. Around the world, you see locations where we have innovation centers, development centers, many of our labs, and proving grounds. Essentially, this is a snapshot of many of our global technology facilities. In 2019, we established a truly exciting technical partnership with VI This has led us to multiple driving simulators, driving simulator systems. The simulators are being located in the US and Europe. We're very pleased to have two compact simulators, the first in our Lux Innovation Center and the second in our Akron Center. We'll install compact simulators across our innovation center. This is the ideal tool for us to prepare models for use on dynamic simulators, allowing our engineers to quickly test new ideas and make sure they will work well when inserted into the dynamic world. We also are excited to have these simulators to further develop and test new ideas, algorithms, and new processes. It will also allow us to expose our engineers to driving simulator technologies. So with that being said, we are even more excited to have our and the first for a tire manufacturer dynamic driving simulator, a VI grade DIM 250, installed this year at our Engineering Technology Laboratory near our Innovation Center in Akron. Let me further illustrate why our tire vehicle engineers, scientists, and test drivers are so excited about this acquisition and our partnership with VI Grade. Next slide, please. The classical V-cycle development process is well known. We have seen this as in a multitude of ways, but it continues to evolve with the many changes in capability. While we work through the initial cycles, on the left side, we also head to the physical side to verify and validate our work and meet customer needs. The simulator at the center of the process, we now bridge between the and before building any physical. We the entire physical process to get back to another round of virtual engineering. Anticipate, and in fact, we fully expect will facilitate development timing and substantially fewer physical iterations in the tire development process. The technical aspects, you can also imagine less physical tire builds means significantly less materials used, less energy consumed and tires, less transportation material, tires, wheels, and people, and finally, less physical. So this is an impact from a sustainability point of view. Next slide, please. This is a view of the virtual development process perspective of manufacturing. The continuous improvement in performance is characterized through many conflicting performance criteria, requiring tire companies to continue innovating to remain successful with differentiating products supporting customer needs. Historically, Goodyear generated data from manufacturing and simulations. With more data engineering techniques, data is creating additional value in tire development, and from this, big data design can be exploited. Then with the use of advanced, and now including drive simulators, design space can be further narrowed down. In the end, our aim is to do one single physical build. We have confidence in this virtual development process becoming reality with a lot from the insertion of the simulators. So now you may be asking yourself, why the confidence in the simulator during the process? So let me explain further. Next slide, please. This is an example of driving simulator output comparing different characteristics along with driver feedback. The benefit of using a driving simulator during the development becomes clearer as insightful data is directly available from the driver's subjective evaluation while obtaining the direct comparable objective information. This allows in-depth analysis of the tire and vehicle performance and a precise, direct link of objective and subjective results. On the left side, the vehicle balance is represented during track driving on 4 different tire configurations. In this study, the driver identified the different configurations correctly and gave subjective feedback in line with our engineering judgment of the different tire configuration modifications. Ultimately, what is the concept delivering? We knew we could get the objective information from vehicles. We have high confidence in our tire models. And as with many companies, there is a high confidence in our subjective and objective test capability in the physical world. But when we made the connection of our models with the driver in the simulator, we proved we could integrate all virtual aspects and deliver a decision that has forever been physically based. This is an example of the critical information we used to determine the need to embrace and insert the simulator into our development process. Next slide, please. When you bring all of this together, the simulation tools we have had all the years, our empirical information, finite element analysis, tire and material guidelines, standards, and experience, we can see the new virtual tire development process something like this. Now, initially, the virtual development approach will mainly focus on ride performance. However, we can see expansion into other performance areas. Beginning with customer requirements, faster and more repeatable virtual iterations can be performed on the driving simulator before any physical prototype tire. And finally, the physical prototype is evaluated on the customer vehicle in the real world. It is also important to note the physical testing is another feedback into the virtual loop to further refine and validate the process. In essence, the goal is to achieve the sign-off or product release virtually, as with one single build that satisfies and validates customer performance requirements. So Gabrielle, if you could stay on that slide, please. The benefits of virtual simulation can be simplified into 3 areas. 1, development efficiency and accuracy. 2, faster speed to market. And 3, future preparation and readiness. We achieve better performance on the first and eventually only physical prototype through virtual pre-assessment. It's possible to get closer to customer targets via highly repeatable and consistent evaluations and data gathering on a dynamic simulator system. This evolution allows us to better integrate the subjective and objective worlds. In terms of being faster, we can significantly reduce the timing of development cycles and be more responsive to changes in customer needs. And as mentioned earlier, we're able to implement virtual iterations in the tire development process. And there are other real benefits. We can prepare for future mobility platforms by validating potential solutions in the simulator environment. Also, the use of simulators allows us to advance our driver and engineer training and preparation. For example, imagine a test driver using the dynamic simulator in preparation for test sessions at facilities such as Road Atlanta, VIR, or the Nürburgring. And many of us have experienced the impact of weather changes on our development cycles. With the simulator, the weather is always perfect for testing. As an operations leader, it's always nice to know the testing plan is going to happen as planned. And of course, we can develop and hold marketing and product knowledge events with and for our customers. One other thought for your consideration. What about business continuity and ongoing operations during challenging times? For example, imagine the positive impact of this process in times when travel and physical interaction between people is difficult or restricted. Next slide, please. As I conclude my presentation today, Goodyear is extremely excited to be part of this conference and working with a partner like VI-Grade, as the following points are clear to us. Simulator technology is truly a key enabler virtual assessments. Increased collaboration with our customers with this type of process during vehicle and tire development will enable increased efficiency and sustainability in our product development work. Fully virtual development. In fact, virtual is becoming reality in the tire industry. Next slide, please. Thank you for your attention. It's been my pleasure to speak at the 2020 International VI Grade Virtual Conference. And I want to especially thank VI Grade for this opportunity today. I'm certainly looking forward to the rest of today's conference and speakers and the exciting presentations to follow.